Hello, everyone, and welcome to the Flagstaff Star Party and Interactive Stargazing, a joint effort of Lowell Observatory and the Flagstaff Dark Skies Coalition. And this is in preparation for live Star Party activities that will be happening at the upcoming weekend at Buffalo Park. Star Party and Interactive Stargazing are brought to you by the following: Creative Flagstaff, Lowell Observatory, Arizona Community Foundation, Northern Arizona University, KNAU, Flagstaff Business News, Calf Country Radio 92.9, the Babbitt Brothers, Arizona Public Service, Sonesta ES Suites Flagstaff, the Flagstaff Festival of Science, Coconino Astronomical Society, and the Arizona Rangers. I'm David Kerner, one of your hosts tonight. I'm an emeritus professor of astronomy and planetary science from Northern Arizona University. And my research specialties in the past have been the formation of planets around nearby stars, together with an interest in astrobiology. My co-host tonight is Dr. Danielle Adams, an expert in Arabian cultural astronomy, and she will share with us a different perspective on the night sky, one that you have probably not heard before. So please tell us more. Danielle.
Sure, thanks, David. So it's good to be with everyone here tonight. I am Deputy Director for Marketing and Communications here at Lowell Observatory. And as David said, I am a cultural astronomer. And so what that means is instead of studying the stars themselves, I study how people relate to the night sky, how they draw the constellations and tell the stories and how that impacts their society. So tonight, it's kind of a double feature. We'll be going through a beautiful portion of the night sky, rich with the stars of the Milky Way, and we'll be talking about both the modern astronomy and the traditions that we see in Arabian astronomy. And much of that gives rise to many of our modern day star names that we use. So it should be quite fun. Thank you, David, for joining us tonight as well. And we'll get started here. So since we're talking about a cultural astronomy topic, this is a great chance to begin with a land acknowledgement. So located in Flagstaff, Arizona, Lowell Observatory sits at the base of mountains sacred to many tribes throughout the region, including the Acoma, San Carlos Apache, Tonto Apache, White Mountain Apache, Havasupai, Hopi, Hualapai, Navajo, San Juan Southern Paiute, Tewa, Fort McDowell Yavapai, Yavapai Apache, Yavapai Prescott, and Zuni, as well as the ancient peoples of the Anasazi, Hohokam, Mogollon, and Sinagua. We honor their past, present, and future generations who have lived here for millennia and will forever call this place home. So tonight, we are broadcasting from Lowell Observatory, and we'll be providing live views of the night sky from our new Giovanni Open Deck Observatory. This is a beautiful public observing plaza with 6 telescopes, each hand-picked for their different ways of capturing the night sky. So tonight, we will be using one of our PlaneWave telescopes, 14-inch, fitted with a Malan-Cam camera. And before we get to that first live view of the sky, let's get started off with a little bit of Arabian astronomy. So this goes back a long ways, and we're going to start off with a piece of poetry from Dhul-Ruma, who died in 735 CE. And he says, "The travelers with dusty and matted hair were cleaving their way through the desert on well-worn roads when the mother of the entangled stars shifted its position." And I love this piece because it's the Milky Way, of course, that is the mother of the entangled stars. And it's such a beautiful description of what we see in the Milky Way. And what he's talking about here is the fact that as the night progresses, the Milky Way's position in the sky shifts as the Earth is rotating. So here we have a view of basically right now what the sky looks like. And this next slide here is just 1 hour later when we'll be ending tonight. So you can see between just this 1 hour of time, how much the Milky Way is shifting in its position. So if you take a look outside and give just a little bit of time to the night sky, even 15 minutes, you'll see that stars are indeed moving, and things out in space are not just static, but there's quite a lot of action happening there. So I'll stop my screen share here and we'll go to our first live view of the night sky.
Thank you, Danielle, for that image. And it's great to look toward the southern horizon at the Milky Way this time of year and a little bit earlier when it's up a little higher, because we're looking at the very center of the Milky Way. We're looking towards the galactic center, and there's a black hole there. And we'll talk a little bit later about how we know that was the center, because people didn't always understand that. It wasn't always apparent. Now here is, I believe we're looking at the Ptolemy cluster, right? M7, is that what we have in front of us? Yes. Okay, and it's, you can see it's not a too crowded cluster of stars. It's named for its discoverer, the astronomer Ptolemy, in the 2nd century. It's at a distance of almost 1,000 light years away. Compared to some of the clusters we'll see later, it's relatively small, but it still has over 700 times the mass of the sun in stars in this cluster. And it's a fairly young cluster. It's only about 200 million years. Fairly young, you say? Well, compared to the age of the cosmos and our galaxy, which the cosmos approaches 14 billion years old, yes, 200 million years old is not very old. Our own sun is 4.5 billion years old. So these are relatively young stars, still in a configuration left over from their formation, and they may stray further apart from each other as time goes on. Shall we go ahead to, speaking of origins of stars, shall we go ahead to M8?
Sounds good.
So we're going to another even earlier origin of star formation happening toward the galactic center. And there's just oodles of this stuff when you look to galactic center. And look at that. It's just a beautiful swirl of colors. It's a nebula, an emission nebula, but it contains another cluster. So you see the stars get sort of crowded in there. And it looks kind of weird, right? There's a dark lane going through the middle of it. Is that just an absence of material? We know now that no, it is not. It's actually a bunch of dust that's blocking out the material in the inner nebula. And inside those dust clouds, there are little globules in which they are dense enough to collapse and form new stars. And the stars that you see there are also pretty new. This is pretty far from us. It's about between 4,000 and 6,000 light years away. That's quite an uncertainty. It's just hard to get a good distance there, but it is what we call an emission nebula. The gas that you see is glowing because it's heated by giant stars, something also called an H2 region. H stands for hydrogen. And this is H2, where the 2 is with a Roman numeral. There's another H2 with a subscript Arabic numeral 2. That's a molecule of 2 hydrogens, but H with Roman numeral 2 is the ionized hydrogen. So the electrons just not clear off it by all the high energy radiation from bright stars. We're gonna expose here. One more thing I'll say about it is that what we have discovered when we look deeper into it are some bright little globules that are called Herbig-Haro objects. And these are bright blobs of gas that have been spit out by forming stars along their polar axes, where jets are ejected due to energy from the accretion of a disk onto the star. And you might wonder how that all works. Well, the short answer is with magnetic fields. And the long answer of how that happens is beyond the scope of this evening's discussion. But there you have it, the Lagoon Nebula. You have to admit, it's a beauty.
It's gorgeous. And David, we have a question from Dulcimerist. What's the dust made of?
Oh, that's a great question. So, in fact, there's been a lot of research in exactly what the dust is made of. We do get some spectroscopic measurements in the infrared of the dust, and we find signatures of silicon and carbon as the kind of nuclei of the dust grains. But then what happens in these dust clouds, they get very cold because they're in the inner parts where they're shielded from the radiation, so cold that things in the gas phase begin to condense and ice out on them as icy mantles. And they can have organic mantles of very complicated organic molecules. They start with simple organic molecules, kind of like methane that freezes out and CO2 freezes out in the mantles. And then they're processed, and we have found quite a library of organic molecules that come from the mantles of these dust grains. But initially, I think what happens is the nuclei, silicon or carbon, these are grains that originally were ejected in dying stars, thrown back into the interstellar medium. And then when density is concentrated, and they can be concentrated in ways that can be opaque, get cold, and then condense out all this organic material.
Awesome. And I believe we were going to look at another object with more dust lanes, right?
Yes, let's go to Trifid.
This is also another beautiful nebula.
One of the best things to do is get a great pair of binoculars and stare at the galactic center and all around there in the late summer months.
Mm-hmm.
There we have it. You can see, maybe if we expose a little longer, you can see a very weird kind of snaky-like dark wavy line, and it goes into 3 parts, hence the name Trifid. And those dust lanes are, yeah, there we go. Look at that. Ooh, cool. Mm-hmm. So now the emitting stuff is a combination of an emission nebula where the gas has been excited and is now glowing, but also a reflection nebula where there's parts of the nebula that are simply reflecting the light of massive stars. And then, of course, we sometimes refer to those dark dust lanes as a dark nebula. That's what's going on in there. So there's also an H2 region here. There is a very massive star in the Trifid. It's an O7 star. An O7 star with a mass of about 20 times the mass of our sun. It's surrounded by a cluster of over 3,000 other stars. Sometimes these massive stars form first, and then all the radiation that they emit compresses the gas and dust around them and triggers further star formation. So we're not surprised to see this big O star surrounded by a cluster of other stars, perhaps triggered by its formation. Now, just for perspective, you see these big stars, they burn their fuel so fast that they do not live very long. And they will live their lives and blow up before some of the stars in this nebula are even done forming. Isn't that crazy? That's just crazy. It always blows my mind. When we look at the solar system, we find fossil traces of some evolved supernova that blew up in the isotopes. And you might think, what a weird coincidence that when one star is forming in a cluster, another star blows up. Well, it's not a coincidence at all. It's a feature of the fact that the very massive stars just don't live very long, and they blow up even as the stars like the mass of our sun are just starting to come into existence.
Wow. Well, we're off to a great start here. And now we'll switch over and take a look at this portion of sky from the Arabian perspective. And so we've got our two telescope operators helping us out tonight, Brian Ray and Sarah Bircher at Lowell Observatory. So go ahead and stop that screen share and we'll switch to the other one. Thanks very much. Okay, so we're going to talk about a couple things first before we get into Scorpius and Sagittarius from the Arabian perspective. And that is that many different cultures around the world have used the stars to mark the seasonal changes throughout the year. And in order to do that, you need to be able to reliably observe a star at a certain location in the sky and at a repeatable time of night. And so there were 4 ways that people did this long ago, and some of these traditions even survive today, where in order to get the time of night, observing just before sunrise, when the sun is in the east here, you could see a star that is rising ahead of the sun, which is called the heliacal rising, or you could see a star that is setting before the sun rises, and that's called the cosmical setting. Those 2 are actually the ones that we're going to focus on tonight. Those are the 2 that were important in Arabian astronomy. But you could also do this in the evening, right after the sun has set in the west. And so a star that follows the setting of the sun is said to be in heliacal setting. And a star that is rising as the sun has set is doing a chronicle rising. So tonight we're going to first look at heliacal rising. So again, this is when the star rises in the east just before sunrise. And so we're going to look at the Scorpion first. So this is the sky as it appears just a little bit ago, 8 o'clock tonight. So here we've got the Scorpion low on the horizon. And this is a piece of rhymed prose that describes what happens when the Scorpion is rising in the morning. So it says, when the Scorpion rises, the valley rivulet freezes, the locust deceases, the hoarfrost approaches, and the rasping shrike ceases. Now, this may seem like a random assortment of things happening in nature, but this is all describing what happens when it gets cold. The Scorpion took about 1.5 months to rise, starting in November and ending at the end of December. So when the Scorpion rises, the valley rivulet, the little streams, freeze. The locust dies because it's too cold. The hoarfrost approaches, right? So when you wake up in the morning, frost is covering everything. And the rasping shrike ceases. This is a particular bird that was really annoying and bothered a lot of people. And so at this time of the year, it migrated away from the region further to the south, so it could be warmer. And so finally people got peace from this terrible rasping shrike. And so if we look at the Scorpion itself, it looks a lot like the Greek Scorpion, except there are these 2 pinchers out in front. And David, I must say, one of the most fun names to say among the star names is Zubin al-Shamali and Zubin al-Janubi. And those come direct from the Arabic. They mean the northern pincer and the southern pincer. But the Arabs articulated the scorpion in many different parts. So you've got the two pincers. These three stars were the crown. The bright red star that we know of as Antares was the heart of the scorpion. And the white stars, one on each side of the heart, were together called the aorta. And there's two of them that represent the aorta, because the aorta is the artery from which the heart hangs when you look at it from a biological perspective. And so they're on opposite sides of the heart itself. And then we've got stars that form the segments of the tail. And then we get to the raised tail. And so we have Ptolemy's cluster in the tail, was observed by the Arabs to be the sting of the scorpion. So it was actually part of the constellation as the very tip, the stinger that the scorpion had. So if we move on, we'll also look at the region that we were just looking at with M8 and M20. So those two nebulae are right here above what we might call the teapot of Sagittarius. In Arabia, these bright stars did not form a teapot or an archer. They formed a group of 8 ostriches. And so here, this piece of rhyme prose talks about what happened when the ostriches were rising. And again, this is coming into the very end of December and the beginning of January. So this says, when the ostriches rise, white becomes the quadrupeds from hoarfrost that ever falls. Upon every grazer the cold comes, and every sleeper it rouses. So again, we have the frost, but now it's a picture of the frost laying on horses, camels, any of these domesticated quadrupeds that are in the field, sheep. And then, of course, the cold is coming upon every grazer, all of these animals that are eating, and the sleeper. The cold causes you to wake up sometimes because it's too cold. It's not comfortable to sleep. And so here again, we have the scorpion, and the ostriches were in 2 groups. This group of 4 stars were the drinking ostriches. And so the Milky Way here was imagined to be a river. And so the ostriches are drinking in the river. These 4 stars were the returning ostriches. And so they've already drunk from the river and they're returning somewhere. Where is that? Well, to their nest. And so this kind of looks like a bow, 6 stars. And this is actually how ostriches lay out their eggs. They space them wide apart so that predators can't rob a whole group of them at one time. They're arrayed out instead. So here we have the ostriches, the drinking ones and the returning ones.
Great.
All right. So let's, I'll go ahead and stop my share. And near to this region of the sky, we have 2 gorgeous planets that are gracing our skies tonight.
I'm pretty sure everybody knows what that is. So this is live, correct?
Yep.
Awesome. All right, there it is, the largest planet in the solar system, with a network of differently colored belts and zones, which have different velocities of circulation on the planet. The largest planet in the solar system is still not quite big enough to be a star. If it was, then we'd be in a double binary star system, and we'll get to talk about that later. But I think one of the most interesting things to me about Jupiter is its set of moons, which are a miniature planetary system in their own right, I should say. And And why do I say that? Well, you know, there's many moons. Oh, there we have them. Oh, beautiful. There's many moons around planets that kind of have odd orbits. They're not in the plane of rotation of the planet. They have high inclinations. Some of them are going backwards. And they're not in the same plane as each other. These are typically objects that were captured by a planet from a smaller material in the solar system at its origin. But Jupiter's moons, sometimes called the Galilean moons, since Galileo was the first to describe them that we know of from his telescope observations, these moons are all round. They're big enough to be round. They orbit in a plane, and they have chemical differences that suggest they too were formed out of a disk around proto-Jupiter, just the way the planets were formed in a disk around the sun. So that makes them, in a way, a mini substellar planetary system. Now, why I think this is interesting, because we'll talk about double stars later, is that prior to our modern age of detecting a lot of planets, there was an argument about whether or not binary stars could have planets. And the idea was that if you had a binary star, then that you wouldn't have planets, that all the angular momentum would go into the stars. And yet I always thought, you know, can't you see your nose in front of your face? Jupiter is telling you the answer to this already. It's a planetary system within a planetary system. And indeed, we've now found that binary stars also have planets around both stars, depending on their separation. And all those people who were excited about the first Star Wars movie when two suns appeared in the sky of Tatooine can rest assured they're looking at some kind of reality action. Mm-hmm. So that's my fun reaction to Jupiter, but it's also a great, beautiful object just to look at. And of course, you know, we've sent these amazing missions to Jupiter. And if you ever want to see incredible pictures, just go online and Google Jupiter from the Juno mission, Galileo mission, etc. And you'll just see the most amazing, colorful cloud formations on this giant planet that you can imagine.
Yeah, just gorgeous.
So there's something else in the sky, right? Nearby.
Yep.
Why don't we check that out? There it is, Saturn with its famous ring system, which is just one of the most beautiful objects to see, especially even in a small telescope. Rest assured that at this weekend's star parties, where there will be many, many, many telescopes out at Buffalo Park, you will be able to find some that will be trained on one or both of these planets, and you can go look at them live yourself. What in the world gave rise to these planetary rings? Well, an interesting thing, we always think of Saturn as the exceptional planet with rings, but you know, all of the giant planets have rings. None of them have quite as exciting rings as Saturn, but they all have rings. And it has to do with the fact that when you put debris from a moon or a collision of a moon really close to a planet, the tidal forces make it very difficult for it to coalesce back into a moon, and it will be spread out as rings. And so Titan has moons as well. Sorry, I just said one of Saturn's moons, and I meant to say Saturn. And Saturn has moons as well, but the big one, Titan in particular, is much farther away from Saturn than its rings. And so it's safe from this tidal tearing apart forces. It's a remarkable moon, full of organics, and the only moon in our solar system to have a very thick atmosphere. And we look forward to sending a mission there sometime and seeing if all that organic goo has led to any primitive form of life. Could be. Who knows?
Yeah, that'll be exciting once we get there. Well, we've also got some other images of these two planets. Sarah or Brian, let's go ahead and stop that screen share. Thank you. And this is an image of Saturn through our historic Clark refractor, which is a 24-inch aperture giant Victorian refractor, 32 feet long. So the image scale is quite large in the Clark. And then this is Jupiter taken through the Clark. But these two planets had a really interesting meeting not long ago, less than a year ago still, on December 21st. Many of you may remember the great conjunction of Jupiter and Saturn. And so this image, it shows the two planets together in one field of view. And this image was taken with our 4-meter Lowell Discovery telescope. And you can see just beautiful detail in each of the planets, but it still just shocks me when I see this. This is not a composite of two different pictures placed next to each other. This is actually how close the planets appear to be in the night sky. Really, really beautiful.
Yeah, it was an astonishing event to see, even without a telescope. Because if you look at these guys, you look at them and you could think they're about to run into each other. But Saturn is more than twice as far away from us as Jupiter. Now, when you see things that are with such a great difference in distance, what are the chances that they'll line up in the sky? Well, the only reason it can happen at all is because most of the planets in our solar system have orbital inclinations that put them sort of close to each other in a big disk. And that's a clue to how they formed, that there was once a disk of dust that coalesced to make asteroids, and these collided and accreted and made the cores of these giant planets, and the gas in the disk then collapsed onto their cores. And their orbits were pretty close to each other. Now, they're not exact. Why is that? Because when you have these populations of big icy or rocky bodies that are forming things, then random collisions in the disk knock things a little bit askew, right? So that's why they don't end up exactly, but they're sure not randomly distributed around the sun. They're in a disk. And then as a result, we get to see these beautiful conjunctions from time to time.
Mm-hmm. Yep. So this happens roughly once every 400 years. So it's going to be a long time before we get to the next one. So tonight, Jupiter and Saturn are located here in our simulated night sky. And Saturn here is in Capricornus, and Jupiter is in Aquarius right now. And this is really close to a group of curious asterisms that were called the auspicious asterisms in Arabia, as-Saud in Arabic. And it is these 10 groups of stars here. Most of them are pairs of stars that you can see easily with the unaided eye are two stars. And if we zoom in a little bit, what you see is that they each have a name, and a lot of these in Arabic, the original star names survive in modern day star names in this portion of sky. But you see the auspice of rain, the auspice of the exalted one, the auspice of the aspiring one. This one here was called the auspice of woolen tents, because this pattern of 4 stars looks like a 3-sided tent with a tent pole right in the middle. And so all of these, we really don't have very much information about these except for their names. There's a few of them that have made it into rhymed prose, but it's really odd that we have this dense cluster of 10 asterisms, and in Arabic they all have the same name. Sa'ad is auspice or auspicious thing, and so it's Sa'ad something. And nowhere else in the sky do we see this name, just in this one section. So, because one of them was called the auspice of rain, maybe it was the case that when these set, it is in the fall, when they set in the morning. And so perhaps that was a sign of the rains that were coming. And so all of them adopted that. Some of them are interesting, the voracious auspice and the auspice of the slaughterer. They're both described as the brighter star eating a smaller star. So yeah, just a curious scattering of asterisms here. Again, this is Capricornus, where Saturn is, Aquarius over here, and then this goes on up into Pegasus. So I'll go ahead and stop my screen share.
Danielle, can I ask you a question while we're moving?
Yeah.
The use of this word asterism, which I presume has a different sound in Arabic, but versus, in our modern astronomy, we differentiate between asterisms and constellations. For example, the Big Dipper is not a constellation, technically speaking. It's an asterism that's part of Ursa Major, which is the constellation. Did Arabian astronomy have such a distinction? Like, were the ostriches a constellation, but the asterisms were something different?
They're not described in that way. So they're referred to by name, but not, you don't see category names, at least early on. Later on, you do see a word used for constellations, but that's more when Greek astronomy has been introduced in Arabia. And I think part of the reason why is we saw in the case of the Scorpion that it's a drawn constellation, like the Greek constellations. But in the case of the ostriches, it was just two groups of 4 stars, where each star is an individual.
You don't make lines.
Right, exactly.
That's interesting.
So, that for myself, I refer to these oftentimes as celestial complexes, because you get groups of different things that are all connected to each other, but don't necessarily draw a complete figure. Here, I use the word asterisms because in Arabic, it's just asrud, which means the auspicious things. It's really just an adjective. And so it was applied oftentimes to stars. And so because they are groups of 2 or 4 sometimes stars, they are by definition asterisms. So that's where that comes from.
Great. Well, I see we've moved on to some more stars here.
Yep, we've got M30.
M30, all right, look at this. It's another cluster of stars, but this one is very different from like the Ptolemy cluster or the other open clusters that we saw in the nebulae. This is a globular cluster. Well, what's a globular cluster? Oh man, these are the coolest things ever. So this thing, we're now looking well away from galactic center, if you remember. In fact, we're not looking in the plane of the Milky Way at all. So we're looking at an object that's quite far away. It's over 27,000 light years away. So that's a lot further than the Ptolemy cluster. So this represents a lot of stars. The total mass of stars is estimated to be 160,000 times that of the sun. Also, most of the stars in the disk of the galaxy are kind of orbiting in the same direction. And some of the globular clusters do as well, but not this guy. This globular cluster is orbiting backwards and above the plane of the galaxy. Now, if you do fitting to all the stars, their luminosities on something called the HR diagram for this cluster, you get an astonishing old age, 12.9 billion years. That's over 2.5 times older than our solar system. So imagine if one of those stars was like our sun and had an Earth with, life that got started on it. What would that life be like if it was billions of years further along than we are. I mean, that's kind of crazy. But that's typical of globular clusters. Two things about them: that they're very old, and second thing, that they don't orbit in the disk of the galaxy, because early in the formation of the galaxy, and note, we think the whole cosmos that we see is just younger than 14 billion years. So this is only a billion years or so after the formation of the universe that this cluster formed. And at that time, the Milky Way had probably not collapsed into a disk. It was more like some weird spherical distribution of small satellite galaxies. And so the globular clusters that formed that early still retain those orbital characteristics. They orbit in the galactic halo and not in the galactic disk. And it's a very cool thing that somebody once plotted the distribution of all the globular clusters and saw that the center of this halo was where we now find our current galactic center. Well, at the time they did that, they didn't know where the galactic center was. You might think, well, how could they not know? Don't you just look at the brightest part? Well, you could, except that there's so much of that dust, again, we were talking about, that it doesn't look, the galactic center doesn't look very, very much brighter than the rest of the Milky Way. So early estimates of where the center of the Milky Way were woefully wrong. It wasn't until people used these globular clusters in their distribution that they figured out where the center was. So here you have it, 12.9 billion years. It's very dense in the center. It's undergone something called core collapse, where a lot of the high density stars have moved to the very center, and it's orbiting the wrong way around the center of the galaxy in a weird orbit. That's M30.
Yeah, and M30 is in Capricornus.
I love globular clusters as binocular objects.
Oh, yeah. It's nice
Let's
too
look at
because,
another one.
yeah,
Sorry.
Maybe M15.
Okay.
It's nice because when you look at globs, as we affectionately call them, one after the other, you start to see the differences, right? They're not all just these dense ball shapes that look exactly the same. They have different characteristics.
Yeah, some people make a whole career of globular clusters, and they would be the people to talk to right now because they could tell you all the details. But you know, one of the things that has some of the very oldest stars in globular clusters have occasionally had estimates that were older than the age of the universe, and that confused the heck out of everybody. Well, that had to do with a problem, and that is the amount of non-light elements, what we call the metallicity in some of these stars, has an effect on how you estimate their age. And one of the interesting things about these really old globular clusters, and this one here, this is M15, yes? Mm-hmm. Is that having formed so early, they may have not had time to build up, because, you know, most of these heavier atoms are made in generations and generations of stars, which cook them up in their center and then blow up and return them, and other stars are made out of them, et cetera. But the very first stars didn't have, you know, a lot of carbon, a lot of oxygen, or any iron. And this changes their lifetimes in the age estimates. And so when people had better models that included what we call the metallicity of the star, then they brought a lot of these age discrepancies back into harmony. And so here we have M15, another globular cluster in Pegasus, and we're going to learn more about Pegasus, I think, from the Arabian view here soon. Mm-hmm. This thing is 33,600 light years away. It has 100,000 stars. They're very densely packed. It's undergone core collapse. And it gets an age of about 12.5 billion years. So Danielle, maybe you'll be able to show us where we can look for M15 in the great square of Pegasus.
Absolutely. So if we can stop this current screen share, before I show you where it is, we also got an image of M15 with our 4-meter Lowell Discovery Telescope. And this here is just a spectacular image showing so many stars resolved right to the core of this globular star cluster. And I love this image because it really does look three-dimensional. I mean, you can see this bright innermost core, just completely blinding light. And then you can see the stars outside of that core resolved. You see points of light, even though they're all kind of smashed up together. So this is also M15 from a rather large telescope. And in the night sky, we are looking right about here, M15. And again, this dot here is Jupiter, and this is Saturn. And you may recognize this square of 4 stars as the square of Pegasus. In Arabia, this was known as the well bucket. And so now what we're looking at is in the poetry here, we're going to look at the cosmical setting. So just as a reminder, that is when the star sets in the west just before the sun rises. And so the sky is starting to get bright as the star is setting in the west. And so this piece of poetry is quite old, about 1400 years old or more. During the autumnal season of fruit harvest, a rain period from the well bucket sent to him rain, while the crossbars hung down low in the sky, but were not yet concealed. So this is very specific. The stars move this way. And so these 2 stars here are the first 2 stars to set. So these stars were low in the sky, but not yet concealed. And if we zoom in on the well bucket here, those 2 stars were together called the front spout, or the first 2 crossbars. And then the other 2, of course, were the rear spout and the rear 2 crossbars. And this business with the crossbars is coming into play here because although today we might think of a well bucket as, a round plastic object, when you're out on caravan traveling by camel, you don't carry those things. And of course, we didn't have plastic back at this time. So the way you make a bucket is you take your leather pouch and then you cross 2 sticks at the mouth of the pouch and tie them together. And so here we have the 2 sticks diagonally, and then these 2 stars are the points where the sticks are tied together with a rope. And so when you do that, then you create a square-shaped bucket with 4 spouts. And then this here going up into modern day Andromeda would be the well rope hanging from the top of the well. And so this is a beautiful piece of poetry where this well bucket is about to set into the western horizon as the rains are coming on the earth. And so the bucket is literally dumping out water into the onto the ground. We're now going to move a little bit over and up in the sky to find our last 2 star groupings here for the Arabian astronomy. And these are the 2 vultures. And I'm going to reveal their names in a little bit. But this piece of poetry here talks about how Arabs would use the positions of the stars through the night to track the progress of the night. So this says, I found no sleep, so I did not sleep during the long night. I observe, do I still see the 2 vultures? And so these are the 2 vultures, 2 very bright stars, with some little stars nearby. And so they happen to be Vega and Altair. So Altair comes from the Arabic An-Nasr at-Ta'ir, meaning the flying vulture. And it was called this because Altair has two smaller stars, one on each side, and they're all in a line as if it's a bird that is flying, soaring through the night sky. Vega in Arabic is the alighting vulture, An-Nasr al-Waqia. And that last word, waqia, is what ended up becoming Vega, because in Latin, a W is pronounced like a V. And so that changed over time. But it was called the alighting vulture because Vega has two stars near it as well, but they form this V shape. And when they're setting, this V shape is up and above behind Vega, just like a vulture that is landing on a surface, probably to eat some carrion, and its wings are raised up above it as it's landing. So these were the two vultures, and these two stars set at the same time. And so it was just a beautiful view in the night sky, the two vultures. And you might see these as eagles, but they are properly vultures in the Arabian tradition. So now I'll stop that screen share and we'll take a look at some of these in our live sky tonight.
Thank you, Danielle. Are we going to Vega first, or are we
This
gonna?
looks like Vega.
Okay. Awesome. I just want to make a quick comment about the fact that in the Greek astronomy, Vega, of course, is in the constellation Lyra, the lyre, which is a musical instrument. Interesting idea. The mythology is kind of fun. It has Hermes stealing Apollo's cows and eventually getting caught and making an instrument out of cow gut. And Apollo is so excited about it that he says, okay, give me the lyre and you can keep the cows. I think that's a funny story. But, you know, the lyre in ancient Greece was the preeminent musical instrument, and comparisons with its tones and string lengths led Pythagoras to an idea about mathematics and astronomy and music that persisted for a long time. And I'm just giving a plug here, I'm going to talk about that on Friday night at the Star Party in a talk called The Music of the Spheres. So if you want to hear more about the relationship between music and astronomy, coming out to Buffalo Park on Friday night. I should say something about Vega, though. Did we move, or are we already still at Vega?
Still Vega.
Still at Vega. You know, Vega was the preeminent zero magnitude star for a long time. And we sent up a satellite to observe in infrared wavelengths in the early 80s. And Vega was going to be the calibration star. Well, at infrared wavelengths, it didn't behave. It was too bright. It had all these extra emission. We now know that that's due to a disk of, you guessed it, dust, more dust, around this A-type star, which is only a few 100 million years old. I actually did some observations of Vega with an interferometry array, and myself and some other people detected the millimeter wave emission from the dust around Vega, which suggests that it too has planets on the inside, and this is left over from planetary formation. That excited people enough that if you ever watched, you know, Jodie Foster's movie Contact based on Carl Sagan's book, the ET engine that moves her around is on a planet around Vega. Well, they were moving off of the idea that at that time that was one of the very few stars for which dust had been detected around. Of course, now we know hundreds and hundreds and hundreds because our telescopes keep getting better. But Vega is just full of interest to any astronomer.
Absolutely. And David, I'm getting word from our telescope operators that we're getting some dew starting to form. So we should probably move on to Albireo and I believe the Ring Nebula, and then wrap up before we get too much dew there.
Well, I'll go ahead and say a few things about Albireo while we're on the way. Albireo is a beautiful, well, there you can see it, a beautiful multicolored double star object. It's not clear if it's an optical double because we get much different distances to each of those objects. So it may not be a natural binary, it might just be two objects that are by chance aligned, but they are beautifully different color. The sort of orangish one is a K giant star, so it's somewhat evolved. And if you do spectroscopy, you find that it itself is a spectroscopic binary, and there have been hints of a third component that are not always verified, so we don't know. So the orange K giant there is Albireo A, and it's a big giant star. Its radius is almost 70 times that of our sun, so that's a big star. Mm-hmm. The bluish star, Albireo B, is what's called a BE star. So that's a B star, which is a pretty massive star, high temperature star. The E stands for emission lines. And so the emission lines are thought to be the result of accretion onto the star. So it would be a very young star. And being a B star, it too would have a fairly short lifetime compared to, say, the sun, probably of order tens to maybe 100 million years at most. So it has these emission lines that suggest it's still accreting. And those are the two stars, or maybe four stars, depending on how many components are hidden in there, of Albireo. It's about 420 light years away, average, because one, I think one is like 400 and the other's 440 or something like that.
Great. And as we move to our last object, M57, the Ring Nebula, I'll just mention that we will be doing our regular first Tuesday of the month interactive stargazing next Tuesday, so a week from tonight. So we will need to get the telescopes protected here and back in their houses, so to say, but definitely you can join us next week for some interactive stargazing.
Thank you, Danielle. We just have a couple minutes, so I'm going to talk fast about the ring. You can see the ring is beautiful. That's most important. Also, you guys, the ring is in the lyre, so you get that when you look at the musical instrument. This ring is a planetary nebula, which is kind of a funny word because it's not a planet. In early telescopes, the size sort of looked like a planet, so that's why they called them planetary nebulae. It is the ejected shells of a star that has moved well off the main sequence. This is a thing our sun is going to do in another 5 billion years or so. As it starts to burn higher order isotope fuels and higher order chemical fuels, it will burn so much energy that it'll blow a lot of its outer layers just clear off. Now, the sun already blows the solar wind towards us, but it's a little bit compared to what will happen when it's burning helium or carbon. And in this case, this material comes out, and in the center is what's left behind. And what's left behind is a very hot object, surface temperature of about 125,000 degrees Kelvin, a luminosity 200 times that of the sun, and it's on the process of cooling down to be a white dwarf of a mass of merely 6/10 of the solar mass. And this is exactly what our sun will eventually do.
Awesome. Thank you, David. So we can go ahead and stop this screen share here and get our telescopes wrapped up. And I'll just return here to acknowledge our sponsors again for the Flagstaff Star Party. And David, do you want to go through that list again?
Well, okay, we'll start off with Creative Flagstaff, which is the biggest contributor, and then big contributors include Lowell Observatory, Arizona Community Foundation, Northern Arizona University, KNAU, Flagstaff Business News, CAF Country, Babbitt Brothers, Arizona Public Service, Sonesta Suites Flagstaff, the Flag Festival of Science, Coconino Astronomical Society, and the Arizona Rangers.
And so this weekend, we have the Flagstaff Star Party happening at Buffalo Park. I believe that is Thursday, Friday, and Saturday nights. Is that right?
Yes. And, the weather looks better for Friday and Saturday than it was looking a little bit ago. So we're hopeful.
Mm-hmm. Yeah, hopefully, well, just like today, we had a huge amount of clouds earlier today, and they just kind of melted away as we got into the evening. So wonderful. Well, thank you, David, for being with us tonight. And thank you to all of you watching. I hope that you've enjoyed our little jaunt through the night sky tonight and a little bit of Arabian astronomy mixed in with that. Again, if you've enjoyed this, next week we'll be doing our monthly interactive stargazing live stream right here on the Lowell Observatory channel. So from both of us, thank you and have a great night.
Thank you, Danielle.